All right, now that we have our server working and fairly functional, it's time to go back and take a look at opportunities for optimization and refactoring. And the astute programmer will probably notice that a few moments ago, I actually copy-pasted this code twice. Anytime you find yourself copy-pasting code, that should be a red flag that maybe there's a better way of doing this to take and modularize this code. Because if we copy paste and we have to go back and maintain that code, every time we've copy pasted that code, we have to find that next instance and change it there as well. And if we go ahead and add all of the code for these 5 images that we're going to serve, that's 5 times we'd have to find that particular chunk of code and edit it, and that is obviously a maintenance challenge. So this is a real good opportunity to refactor our code, to actually rewrite our code in a slightly better form. And what we're going to do is we're going to encapsulate that operation of reading in the file and serving it in its own function. We'll call this serve image. And we'll just take that body of code from one of these and put it into the body here. And this, of course, suggests a couple things we're going to need. First off, we need to be able to change which particular image we're loading, and we determine which one we're loading by a file name. So let's go ahead and create a parameter called file name, and then we'll just concatenate that with the directory, because the directory is not actually going to change. And that will allow us to load that file. You'll notice we're also using the response object, so we need to pass that in. And I'm going to go ahead and take the request object as a method parameter here as well. It's not strictly speaking necessary, but request and response are just pretty much always used as a pair in web programming, so it's a good idea to go ahead and pass those in case at some future point we do need to take advantage of the request inside the body of this function. It will already be there, and the overhead for passing it as well is really negligible at this point. So we'll come on down into the body here, and we're going to replace this with a call to that function, serve image. And of course, this is the chess.jpg image we want to serve. And we're going to pass that request and that response object. And then we can do the same thing here and replace this with the fern.jpg and our request and response. So we'll save this change, and we'll go ahead and restart our server. And we should see, if we refresh, we still get our chess image, and if we put in fern, we get our fern image. So this is doing exactly what we expect, but now we have our code restructured in a way that makes it much more maintainable, because if we ever need to come in and make a change, we only have to make the change here. And actually, that's a good opportunity to segue into the next change we want to make, which is actually a change to improve the efficiency and reliability of the server. The fs.read file sync is a synchronous operation, which means our execution is going to pause at this point while we contact the file system and read in this image and store all of its contents in a buffer, and that buffer is going to be then bound to this data variable. Anytime we go to the file system, that is what we call an expensive operation, and it's a blocking operation in the sense that if some other process on this computer is already reading from the hard drive, we will not be able to read from that hard drive until that other process finishes. So the challenge is, if we have a request coming in and we start processing that on the server, but we have to wait for the file system return, we'll have more requests coming in, which are actually just going to keep piling up on the server in the incoming message queue. And we can't actually process any of those until we finish that first file server response. Because if you remember, all of our code, all of our examples in the switch statement are all serving these images, so they are all using the file system, and these will all become blocking calls. So this will work fine for a few users, but once we start to scale, it's going to get ugly fast, and we're going to see some really slow response times. So the better way of handling this is what we call an asynchronous method. And in Node, the read file is the asynchronous version of sync. You'll notice we don't actually have async as part of the function name, and that's because in Node, asynchronous operations are the default idea. And what's different about an asynchronous function is we actually supply a callback. And that is going to be the function that gets executed when the file system returns that file. So we actually will hit this point, we'll read in our file, or start reading in our file, and that actually gets spun off on a new process, and then we immediately continue execution below here. So we're going to take these guys, we're going to put them up here in the body. So what happens now is if somebody requests chess, execution comes into this request.url, we come down to serve that image, and the serve image will start reading this file, which is spun off on an asynchronous thread, and we immediately finish execution here, and that brings us back to the return value for this image, and we hit our break, which exits us out of the switch statement, and then we end the functions, we're out of the function as well. So immediately the Node server can go back to listening for new requests and processing those requests. And when this file system finishes reading in that file, it's going to trigger this callback function, which is then going to send the actual response. Now there's another thing to note in this callback function, and that's the first parameter here is the error function. This is a very common pattern in Node asynchronous operations. Basically, the error is a parameter where we can put in any kind of error object, an error string, or an actual object, or maybe a numerical error code. Basically, any value in that error parameter indicates something went wrong as we're doing this function, and we should not expect this data variable to actually contain the data that we want. And this is a common pattern because in JavaScript, we can actually check for truthiness. So if this is set to a numerical value or a string for an error code or an error object, all of those are truthy in JavaScript, which means if we put them within a Boolean test, they will evaluate to true. On the other hand, if there's no error, this would normally contain null, undefined, or false, all of which evaluate to false, which means we would never execute this branch of code, and we'd come down and run through our header. So this gives us a really easy way to catch errors and handle errors within Node asynchronous functions. If we do have an error, one of the things we'll probably want to do is log that to the console. So we could use console.log and pass in the error, but I actually prefer to use console.error, which also logs it to the error, but it can put it in a separate log if we have our system set up that way, which is specifically for errors. And usually it will also earmark that as an error rather than just a regular debug message in the log. And it's just good practice. So there we're going to log in our error. And then because we're not going to be able to serve the file, we need to, just like in this default case, provide some kind of message to our user telling them why or what went wrong with this process. So we are going to set status, and the status error code in this case is going to be something in the 500s, which indicate a server error. So something went wrong on the server. It isn't necessarily something the client needs to know exactly what went wrong. They just need to know that there was a problem. And this is actually status code, not set status, and status message server error. And finally, we have to send that response. Otherwise, if we have an error, we'll actually hang just like we did before. And we want to return because we want to actually, if we have an error, we'll execute all of this code. And then we want to exit out of this callback function before we actually execute the code that expects data to actually hold a value. So if we save this, go back and restart our server again, and if we try to load our fern, you see that works exactly like we expect. Chess also works. So there is no obvious difference to us in the execution of the code on the client side. But on the server side, this is a much more efficient way of serving images by taking advantage of asynchronous functions' non-blocking nature. So you might be wondering, well, if that's the case, then why do we even have the synchronous functions defined? And there are some occasions where that actually makes a lot of sense. For example, in this particular gallery example, we only have 5 images. That's not a whole lot of images. And if we're going out and loading these from the file system every time we want to take a look at those, that's going to take a certain amount of processing and a certain amount of file access. We actually have an opportunity to be far, far, far faster by actually caching these images in memory. And what we would do to do that is we'd need a variable for each image. So for example, we could do fern, and we're going to go back to fs.read file sync, and we will load images fern.jpg, and then we'll do the same for chess. And in this case, we would not actually serve our image using that serve image function. Instead, we would want to just serve the cached file. Response.end and chess. And of course, we'd want to send the content type, but I'm going to skip that for right now because this is just a quick demonstration of how caching could work. Semicolon. Let's restart that. And if we reload chess, works fine. Fern works fine. No functional differences that we can see. However, the difference is that because these are actually stored in memory in RAM in their binary form, we can immediately send those. So there's no going to the hard drive in this case, which tends to be a somewhat expensive process in terms of the amount of time it takes. And we've now alleviated all those blocking concerns as well. So this is a very efficient way of caching and serving images when we have a very small number. Now, the problem why we can't do this when we have a large number is it will actually consume all the space available in our RAM, and usually at that point our operating system will start using paging, so it will actually save some of the RAM to our hard drive to emulate extra RAM that it doesn't have, or what we call virtual RAM, and that it brings back the slowness of actually accessing the hard drive, and can lead to page thrashing, which can actually really hurt performance even further than that. So this style of caching really should only be done if we have a small number of files or a reasonably small size of files. But the reason we want to use read file sync here is we actually do want to pause execution of this code while we read in and cache those files, because we don't want to start listening and serving those before these are completely read. So that is one use case where the read file sync actually makes a lot of sense. So that wraps up our discussion for servers and our creation of a simple gallery server. Now, we do still have some other images that we need to add to this, but I will leave that as an exercise for you.